So in the last class, what we have discussed about the dining philosopher problem, and we have given a solution of this particular problem using semaphore. Okay, and what was the solution? I am just writing the solution. So the solution was that there are some philosopher and these philosopher will follow some rule. What they will do is they have only two work. They are thinking and they are eating. For thinking, there is no problem. Anybody can think because it doesn't require any resource. But just before the eat operation, just before eating, they have to do something. So first thing they have to do is they have to do a weight operation on chopstick. A chopstick, and second they have to wait on I plus one chopstick, and then they have to eat, and at last they have to do signal on the chopstick I, and they have to give the signal on chopstick I plus 1 mod 5 in that way. Now we have this semaphore in the form of the array. That is called chopstick. The array is called chopstick, and having the index value from 0, 1, 2, 3, 4 for five philosopher, and the initial value of these array is 1. And we can also give the numbering like this is 0th philosopher, this is 1, this is 2, this is 3, and this is 4th philosopher. And the chopstick is, let's say, this is 0th, 1, 2, 3, and this is 4 chopstick. Okay. So here what we are allowing is we are allowing the philosopher to eat whenever there is a 2 chopstick available. Then we'll allow the philosopher to eat. For that, the solution has been given. I have explained the solution, and I have shown that there will be no problem that whenever philosopher want to eat, they have to pick up 2 chopstick. One chopstick is from the right, another chopstick from its left. Means if 0th philosopher want to eat, it has to pick up the 0th number chopstick first, means it is in the right, and then it has to pick the 1 number chopstick which is in the right. In the left. So right and left is the sequence. Now, what was the problem that we have find it out? Let's go through the problem. The problem is, let's assume that philosopher number 0 has initially want the chopstick. So, want to eat. Then it has to wait on chopstick I. I is 0. So 0th number chopstick, they have to make it wait. Once they will make it wait, this 1, the value of 1 will become 0 because the wait operation will do that. And then P0 means philosopher 0 will get 0 chopstick. Then here there is a preemption. Preemption means the process will be deallocated from the CPU. Now here what is happening is, let's say P1 want to eat, and P1 is getting the CPU, then P1 will do the wait on chopstick 1 because I is here 1. So it can do the 0, it can wait here on chopstick 1. So this value of 1 will become 0 on wait, and then again the preemption will be taken place, means philosopher number 1 is picking up chopstick number 1. So chopstick number 0 is the with philosopher number 1. Chopstick number 1 is with philosopher number 1. Let's go to philosopher number 2, and 2 want to eat. Again, it has to do the same thing, wait on 2. So when it will do wait on 2, it can do it because the value is 1. We can make it 0 while waiting, and P2 will get a chopstick number 2. The same thing will happen to 3 also. 3 can also wait on the third chopstick, and third chopstick will be assigning to P3, and then there is a preemption. So 2 will be given to second number, 3 will be given to third number, and P4, which is the fifth philosopher, is asking for eat. So it will pick up the first chopstick, which is in their right, which is the fourth number chopstick. It can get it. Why? Because the wait will be done. Once the wait will be done, they will assign the chopstick, and after that there is a preemption. Now when again P0 want to execute, after that it has to execute this code. This code says that for 0, 0 plus 1 means 1, 1 mod 5 is 1. So chopstick 1 on wait on chopstick 1. Can it will do wait on chopstick 1? It cannot do because it is already 0, which is the semaphore value is not greater than 0. It is actually 0. So here there will be a busy wait, and this wait function is not going to execute. So P2 is waiting for P1 to release. Sorry, P0 is waiting P1 to release, but it will not get. At the same way, P1 will also wait on I, that is 1 plus 1, that is 2, second number chopstick, and it will not get it because it is held by philosopher number 2. The same thing is happening. It is waiting for third chopstick, but it will not get it. It is waiting for fourth chopstick, it will not get it. It is getting the fourth one, but it is waiting for the 0 chopstick, but won't get it. So everybody here are having some resource and waiting for another resource. So you can see here how the thing is done. We have philosopher 0, and we have how many resources? We have actually five resources are there. 1, 2, 3, 4, 5. 5 chopstick, 5 resources. Okay. So P1, P0 is having 1 resources. Is having 1 copy of resource, and P1 is having another copy of resource, right? Now P2 is having 1 copy of resource, and P3 is having another copy of resource. and we have another chopstick available. And there is a P4 who is having that copy of resource. So I'm just numbering the chopstick 1, 1 chopstick 1, chopstick 2, chopstick sorry, this is 0th number chopstick 1, this is 2nd number chopstick 3rd, and this is just 4th number chopstick number 4. Okay, now this line will tell that these resources are available with the process or the philosopher. Now I'll draw another line which tells us the waiting line. So P2 is waiting for P1, right? Why it is waiting for P1? To release, sorry, yes, P0 is waiting for P1 to release 1, right? Now what P1 is doing? P1 is waiting for P2 to release this 2nd number chopstick. P2 is waiting for P3 to release this 3rd number chopstick. And P3 is waiting P4 to release this 4th number chopstick. And P4 is waiting P0 to release the 0th number chopstick. So you can see the waiting here is the line which tells you about the waiting, that is called wait for graph, which is shown in the red color. So how it is look like? It look like this. So we have P0 is waiting for P1, P1 is waiting for P2, P2 is waiting for P3, P3 is waiting for P4, and P4 is waiting for P0. So if in the graph, in the wait for graph, we got a circle. We got a circle. If we got a circle in the wait for graph, then there is a deadlock. Okay, this is how we can find it out, or we can detect that there is a deadlock. So why deadlock occur? Because one philosopher is holding the chopstick and waiting for another philosopher to release the chopstick. The same thing is happening with all the philosopher, and your system can go to the deadlock. Now let's try to find out the solution for this type of deadlock. Okay, so here we are looking for the solution. This is the solution for the Danning philosopher problem, but this solution has a problem. What is the problem? The problem name is deadlock. So we are looking for the solution for the deadlock. So the first solution related to the deadlock would be simple one. What we can add one more semaphore. So we have a semaphore which is called chopstick. We'll add another semaphore which is called S. And the value of S will initialize with 1. The philosopher who want to eat has to first wait this particular semaphore. This is P is for wait, right? We know that wait is nothing but P, and signal is nothing but V. Okay, that thing we have seen earlier. So here let's say that if a philosopher want to eat, it has to first make a wait on S, and then after getting the chopstick, it will make a signal that is called Vs. Now, if we'll do that, is there any deadlock? Let's see. Do we have any deadlock if we'll do this solution, or if we'll keep this solution with us? Are you all with me? You pay the attention in this solution, okay? So what we are doing is we are just, after the thinking, we have a weight. And after this last weight, we have a signal. Let's go for the philosopher number 0. What he want? Philosopher number 0 want to eat. And one more thing, the initial value of all the chopstick is 1, means all the chopsticks are available. Let's go for P1. Now P1 want to eat. So what P1 has to do? Previously it was thinking, now it want to eat. So it has to do PS. PS means weight on S. When it will do weight on S, so S value will become 0. Once the S value will become 0, because it can done, right? Because the semaphore is 1, we can make it 0. So this will execute. After that, it will go to the weight. Now, once it will go to the weight, weight of chopstick 0 is also available. So we can do a weight on it and we can make it 0. Now P0 को क्या मिल गया? P0 को मिल गया 0 number का chopstick. Now what? Now P0 has been preempted. जैसे हम लोगों ने पहले देखा था, मान लो preempt कर गया. अब क्या करेंगे? What we'll do? Now P1 want to eat. Now P1 want to eat. P1 अगर eat करना चाह रहा है, so P1 was thinking previously, now it want to eat. Then it has to do PS. अभी S की वैल्यू क्या है? S की वैल्यू तो 0 है. PS परफॉर्म होगा क्या? वेट परफॉर्म होगा क्या? वेट परफॉर्म नहीं होगा. क्यों? Why? Weight is not going to perform. मैंने इसको वेट भी लिख लेता हूँ, ठीक है? So कोई कंफ्यूजन ना हो आपको. और ये हो जाएगा आपका सिग्नल. अभी ये वेट परफॉर्म होगा क्या? नहीं होगा, बिकॉज S वैल्यू इज ऑलरेडी 0. इट विल बी एन अ बिजी वेट. सो P0 को कोई चॉपस्टिक मिलेगा? नहीं मिलेगा, क्योंकि वो यहां तक के पहुंचेगा भी नहीं. गेटिंग इट? मान लो P2 आता है, रिक्वेस्ट करता है, अगेन इट हैज टू डू वेट ऑन S, बिकॉज S इज ऑलरेडी 0. इट कैन नॉट डू दैट. सो कोई भी फिलोसोफर आए, वो चॉपस्टिक नहीं मिल सकता उसको. क्यों? क्योंकि ऑलरेडी P0 के पास 0 नंबर का चॉपस्टिक है और एक सेमाफोर भी यूज कर लिया गया है, जिससे कि और दूसरे किसी फिलोसोफर को चॉपस्टिक मिल ही नहीं सकता इस कोड के अनुसार. जिससे कि P0 को अगर ईट मतलब खाना है तो वो क्या करेगा? प्रीएम्प्ट तो हो गया, मान लो फिर से आता है तो चॉपस्टिक 1 उसको अवेलेबल हो जाएगा. क्यों? क्योंकि 1 तो किसको मिला ही नहीं. तो 0 और 1 मिल गया किसको? फिलोसोफर नंबर 0 को. वो खाया, खाने के बाद उसने रिसोर्स को रिलीज कर दिया. जैसे ही रिलीज करेगा क्या होगा? हमारा चॉपस्टिक यहाँ पर अवेलेबल हो जाएगा. ये 0 हो जाएगा 1 से, ये 0 हो गया था क्योंकि हमने दे दिया था, ये भी हो जाएगा 1 से, और हमारा ये सिग्नल आ जाएगा. सिग्नल आ जाएगा तो ये हो जाएगा 1. जैसे ही 1 हो जाएगा, नाउ अदर फिलोसोफर कैन गो एंड कैन eat. So this is one solution to the deadlock. Now यहाँ पर हम लोग क्या कर रहे हैं? एक सेमाफोर बढ़ा दे रहे हैं. सेमाफोर बढ़ाने से हमारा मेमोरी भी it will utilize more. ठीक है? Can we give a solution which is with the same semaphore? We doesn't have to add a new semaphore. We don't want to add new semaphore. Can we give the solution? So as I told you, this is the one solution. Can we give other solution? Yes, we have some more solution which is without adding the extra semaphore. Now what is the solution? The solution is, the first solution is, can we allow only 4 philosophers at a time? 0, 1, 2, 3. will not allow the last philosopher. अगर हम लोग अलाउ नहीं करते तो क्या होगा? मान लो ये सॉल्यूशन है ही नहीं हमारे पास, कौन सा? एडिशनल सेमाफोर का सॉल्यूशन नहीं है, तो हम लोग क्या सॉल्यूशन दे सकते हैं? We can give a solution where we assume that at a time only 4 philosophers are active, and in that case what will happen is, let's say philosopher number 0 को 0th चॉपस्टिक मिला, उसके बाद प्रीएम्प्ट हुआ। 1 को 1 चॉपस्टिक मिला, उसके बाद प्रीएम्प्ट हुआ। 2 को 2nd चॉपस्टिक मिला, उसके बाद प्रीएम्प्ट हुआ। 3 को 3rd चॉपस्टिक मिला, उसके बाद प्रीएम्प्ट हुआ। और हम बोल रहे हैं कि 4th इनएक्टिव है, तब क्या होगा? 3rd को मान लो प्रीएम्प्ट हुआ, उसके बाद मान लो 0 को नेक्स्ट चॉपस्टिक मिलेगा क्या? 1 मिलेगा? नहीं मिलेगा। 2 को नेक्स्ट चॉपस्टिक 3 मिलेगा क्या? नहीं मिलेगा। 3 को नेक्स्ट चॉपस्टिक 4 मिलेगा क्या? मिल जाएगा, क्योंकि 4 को कोई उठाया नहीं। सो ही विल गेट द 4th वन। Now, because P3 is getting both the chopstick, it can eat and then release. Once it will release, he will get, once it will release, he will get. Okay, so we are getting, the first solution is to add extra semaphore. इसमें हमने देखा it will require more memory. Second solution is 4 philosopher would be active at a time. This is the second solution. Okay, let's go for other solution. कोई और solution हो सकता है क्या? Can we make any other solution जिसमें हम लोग चारों फिलोसोफर रहेंगे? चारों फिलोसोफर जो हमारा पहला डेफिनेशन था, that should be fulfilled. Means all the philosophers are there, all the philosopher can think at a time, all the philosopher can eat whenever they want. So there is no restriction on that. Can we do that and still can we give the solution? So the answer is yes, we have another solution. What is the solution? The solution is this, that will allow all the philosopher except one to reverse the chopstick pickup method. Means पहले क्या हो रहा था? पहले 0 नंबर चॉपस्टिक लिया जा रहा था, फिर 1 नंबर चॉपस्टिक, मतलब पहले राइट फिर लेफ्ट। सो पहले क्या था? राइट चॉपस्टिक था, उसके बाद लेफ्ट चॉपस्टिक था, राइट था, लेफ्ट था, राइट था, लेफ्ट था, राइट था, लेफ्ट था। अभी कोई एक को हम लोग क्या कर देंगे? बोलेंगे तुम पहले लेफ्ट को उठाओ फिर राइट को उठाना। इफ विल गिव दिस सॉल्यूशन, can we preempt the, or can we avoid the deadlock? So the answer is yes, we can do that. So in this case what will happen is P0 will get the chopstick 0, then preempt. P0 will get the chopstick 1, then preempt. P2 will get chopstick 2, then preempt. P3 will get chopstick 3, then preempt. Then for P4, we have a restriction. Restriction is it has to pick up the left one. Left one means it has to pick up the 0 first. Because 0 is already occupied, P4 cannot pick anything. So 4 is already free. So 4 will be given to philosopher number 4 later on. Then because philosopher number 3 is getting both the chopstick, it will eat and it will release the chopstick at any point of time. So philosopher number 2 will get that particular chopstick. Then once this philosopher number 2 has done its eating, then philosopher number 1 will get it. Once they will done its eating, philosopher number 0th will get it. So what I want to say is, if we'll do this solution, then there will be no deadlock. Right? So this is your third solution. Third solution is everyone except one philosopher pick the left chopstick first, then right chopstick. Okay, so it should pick up left chopstick first, after that right chopstick. This is another solution. What else? और कुछ solution बना सकते हैं क्या? Yes, we can make some more solutions. What is the solution? The solution is very simple. For the even and for the odd. Let's say for the even philosopher, we are making a rule of right first and then left. For the odd, we are making the rule left first and then right. For the even, we are making the rule right and then left. And for the odd, we are making the rule right and the left and then right. And here also, because it is a even one, so we'll have a rule right and then left. तो यहां पर क्या करना पड़ेगा? यहां पर करना पड़ेगा if I mod 2 is equal to 0 है क्या? मतलब I even है क्या? अगर even है तो ये परफॉर्म करेगा, else इसी का उल्टा कर दो, मतलब वेट कर दो I plus 1 mod 5 पहले एंड देन वेट कर दो I पे. समझ में आ रहा है? तो इसको उल्टा कर दो. पहले चॉपस्टिक ये जो राइट उठा रहा था उसको हम लेफ्ट कर दिए और जो लेफ्ट उठा रहा था उसको बाद में कर दिए. सो ये कंडीशन आप कर दो. Is this a solution? Is okay for the deadlock? Yes, it is. It is very much okay for the for preventing the deadlock. कैसे? Philosopher number 0 है, क्या है वो? Even है. Even क्या करेगा? Right पहले उठाएगा left, मतलब even ये वाला पहले करेगा, मतलब 0 को पहले उठाएगा. मान लो preempt हो गया तो क्या होगा? Philosopher number 1 आया. 1 क्या है? Odd है. Odd क्या करेगा? राइट वाले को पहले उठाएगा, मतलब कि 1 क्या करेगा? 1 plus 1 मतलब 2 को पहले उठाएगा, उसको मिल जाएगा. मान लो प्रीएम्प्ट हो गया. अब 2 आ गया. 2 क्या करेगा? 2 को पहले उठाने की कोशिश करेगा, बट 2 तो ऑलरेडी गया हुआ है तो इसको कुछ भी नहीं मिलेगा. 3 को क्या 3 क्या करेगा? 3 इज ऑड, इट हैज टू गेट 3 plus 1 राइट फर्स्ट, मीन्स लेफ्ट वाला फर्स्ट. सो इसको फोर्थ वाला चॉपस्टिक पहले मिल जाएगा. फिर मान लो प्रीएम्प्ट हो गया. फिर P4 क्या करेगा? is a even one, so P4 will pick up its fourth number want to pick, but fourth number is already assigned to 3, so it will not do anything. Is there any chopstick free? Yes, the number 1 chopstick is free and it will be get after some time to philosopher number 0. So philosopher number 0 को मिल गया chopstick. कुछ टाइम के बाद 1 तो किसी को असाइन होगा नहीं, राइट? एंड फिर उसके बाद ये ईट हुआ. ईट करने के बाद रिलीज करेगा तो किसको मिल जाएगा? 1 इसको मिल जाएगा. और 0 किसी को चाहिए क्या? 0 अभी नहीं, किसी को नहीं चाहिए. एंड देन इट विल रिलीज इट. सो अभी 2 इसको मिल गया. और आई थिंक इट रिक्वायर्ड 0 1 1 2 2 एंड 3 ऑलरेडी फ्री है, सो 2 के बाद इसको 3 मिल जाएगा. जब ये हो गया तो इसको मिल जाएगा 3 आफ्टर दैट, एंड देन इट विल गेट, when it will be released, it will get 4. 0 is already free and 0 will get. So this is another solution for this problem, which is called the dying philosopher problem. On that we have seen the problem of deadlock. अभी deadlock से कैसे हटना है या कैसे उसको solve करना है, we have many solutions. Okay, so